think about what it might mean for triangles to be similar. What do you think makes similar triangles different from congruent triangles? You might be thinking, congruent triangles are exactly the same size and shape. So maybe similar triangles aren't exactly the same. Maybe they have different sizes. If you were thinking that, you'd be absolutely correct. Let's talk about what it means for triangles to be similar. So here we have 3 different pairs of triangles, and we're going to talk about why each pair of triangles is similar. If you take a look at the first pair of triangles, notice how corresponding angles A and D are congruent, and corresponding angles C and F are also congruent. Since this is 60 and this is 70, and same thing in this triangle, corresponding angles B and E have no choice but to also be congruent. 60 plus 70 is 130. So that means the last angle in each of these triangles needs to be 50 degrees to make the 180 degrees that all triangle angles always add up to. So what we see here is that we have 3 pairs of congruent corresponding angles. Since 2 pairs of congruent corresponding angles implies that the third pair also has to be congruent, it's enough to say that these 2 triangles are similar by AA. We don't need AAA. It's the same thing as AA. AA means we have 2 pairs of congruent corresponding angles like we had here. And that's one of our ways of proving triangles similar. Here's our next pair of triangles. Notice, to get from the sides of the smaller triangle to the corresponding side of the bigger triangle, we're multiplying by 2. Same thing with these corresponding sides, and same thing with the corresponding sides, the bases over here. We say that these 2 triangles have proportional corresponding sides. And in fact, they're proportional by a scale factor of 2. In order to find the scale factor, you can take a side of the bigger triangle and divide it by the corresponding side from the smaller triangle. And there we have the scale factor of 2. One property of similar triangles is that the corresponding sides are proportional. Here, since we have 3 pairs of proportional corresponding sides, we say that these triangles are similar by SFS. That's also one of our ways of proving triangles congruent. But remember, when we were talking about congruent triangles, the corresponding sides had to be congruent. In similar triangles, we're not talking about congruent sides. We're talking about proportional sides. The last pair of triangles have 3 pairs of proportional sides as well. To get from the smaller triangle to the bigger triangle, to get from one side to the corresponding side, we are multiplying by 3. So there is a scale factor of 3 to get from the sides of the smaller triangle to the corresponding sides of the bigger triangle. If we were going from the bigger triangle to the smaller triangle, the scale factor wouldn't be 3, then the scale factor would be 1/3 because we would be making every measurement 1/3 smaller. So we can say that these 2 triangles are also similar by SSS, since there are 3 pairs of proportional corresponding sides. But notice how there is also a congruent angle. Angle C is congruent to corresponding angle C prime. So what we have here also is we have 2 pairs of proportional corresponding sides with a congruent angle in between. This is SAS. SAS for similarity is different from SAS for congruence. When we're talking about congruent triangles, SAS means congruent sides with a congruent angle in between. When we're talking about similar triangles, we're talking about proportional sides with a congruent angle in between. So similar triangles always have proportional corresponding sides and congruent angles. So these are our three main ways of proving triangle similar: AA, SSS, and SAS. Let me zoom this in a bit bigger so that we can see it. Once again, just our three ways of proving triangle similar. We have AA, that's two pairs of congruent corresponding angles. We have SSS, that is three pairs of proportional corresponding sides. And we have SAS, that is two pairs of proportional corresponding sides with a congruent angle in between. For each of the following, we're going to determine if the triangles are similar or not and why. So I see intersecting lines. So that means we have congruent vertical angles. I'm thinking it might be SAS because we have information about the sides next to the angle, but we need to verify that the corresponding sides are in fact proportional to each other. So to get from 12 to 24, that's multiplying by 2. But to get from 16 to 31, that's not multiplying by 2. 16 times 2 would be 32. So since the corresponding sides don't have the same scale factor, that means they're not proportional. So although it seems like this might be SAS, these triangles are actually not similar because the corresponding sides are not proportional by the same scale factor. Let's take a look at number 2. We have a 90-degree angle, and we have a 62-degree angle in the first one. So what I'm going to do is I'm just going to find what that last angle needs to be to make 180 degrees. So 90 plus 62, that's 152. Subtract from 180, that's 28. So we do have two pairs of congruent corresponding angles. So the triangles are similar by AA. Let's take a look over here. We have the smaller triangle, and we have the big triangle. These corresponding angles are congruent, so that's one pair. And then we have the shared angle at the top. Notice how this angle is both in the small blue triangle and the small red and the bigger red triangle at the same time. So we can say this angle is congruent to itself by the reflexive property. So what we have is two pairs of congruent corresponding angles. So these triangles are similar by AA. Here we have parallel lines. When we have parallel lines, I like to highlight them, and I like to highlight the transversal that intersects. Then we see that we have a letter Z, and in the corners of the letter Z, we have alternate interior angles. They're inside the parallel lines on different sides of the transversal. And alternate interior angles are congruent when we have parallel lines cut by a transversal. And these angles are vertical angles, so they are congruent to each other. So we have the triangles are similar by AA. Pause the video and try these next ones out for yourself. You can check your answer. In number 6, the corresponding sides aren't all proportional by the same scale factor. Try out the next two, pause the video, and here you can check your answer. In number 10, we don't have enough information. Let's skip that one, and let's come over here. So the last thing I want to talk about in this video is that when we have similar triangles, the corresponding sides are proportional. So we can set up a proportion to find missing side lengths. So keep in mind that the letters in the triangle name tell you what parts are corresponding. For example, AP, first two letters correspond to YK. AC, first and third letters, would correspond to YM. So keep in mind that the order of the letters, when we have triangle names, tells us which parts correspond to each other. When I set up proportions, and there's multiple ways to set up a correct and valid proportion, I like to always set it up the same way. Side from small triangle over corresponding side from big triangle equals side from small triangle over corresponding side from big triangle. So I'll take the 32 first, aside from small triangle. That's AP. So the corresponding side to it from big triangle would be YK. Another side from small triangle is 12. And that is PC. So that corresponds to KM. When we have, oops, I'm low power here.